All right, so let's go ahead and try out this next example. So we want to find the partial fraction decomposition of this beast. So the first thing that we want to do is factor out this denominator because this time it looks a little more complex. So the top guy we always want to keep by itself. So we're going to have negative x squared plus 2x plus 4. And on the bottom, it looks like I can take out an x. And we're left with x squared minus 4x plus 4. All right. And now on the bottom, it seems that I can go ahead and just factor a little bit more. So here, it seems like you're going to have x and x and a 2 and a 2. And I think they both should be minus. And you can see that these two guys are repeated. They're the same ones. So you got negative x squared plus 2x plus 4 divided by x and then x minus 2 squared. So now I can go ahead and write this as partial fractions. So you can see that now I have one non-repeated at the x and then a repeated x minus 2. So I'm going to write x minus 2, the first x minus 2 here, and then x minus 2 squared there. It's going to be a b and it's going to be a c. Okay. So now we need to figure out what a, b, and c is. So now the good thing is that the setup is probably the one thing that is going to be a little different. But in this case, the problem itself is the same. So we're going to write down exactly the same thing, x squared plus 2x plus 4 divided by x minus 2 squared. And this is going to be equal to a over x is b over x minus 2. And then the c over x minus 2 squared. And what I'm going to do is multiply everything by whatever the denominator was, the factor for the denominator. So I'm going to multiply this guy by x times x minus 2 squared. This guy by x times x minus 2 squared. This guy by x times x minus 2 squared. And this guy by x times x minus 2 squared. So you can see here, both these guys cancel out. So you're left with negative x squared plus 2x plus 4. Here you see that an x cancels out. So you get a x minus 2 squared. Here, you have to be very careful. You have one x minus 2 cancels out one of the x minus 2's, but you still got one left. So you're left with bx x minus 2. Just one x minus 2 left. Here, the x minus 2 squares cancel out both of the x minus 2 squares. So you're just left with cx. Okay. Now here is where it can be a little tricky because you do have to set up a system of equations and FOIL everything out. But I'm going to show you a little trick. The trick doesn't always work, but it does in this occasion. So one of the things that you can do is plug in a number in here so that a lot of things can go away. Because remember, this is an equality. So any value of x should be true for all of these guys because this is an equality. So one of the things that we want to be able to do is solve for one of these variables. Notice that in here, in the x minus 2 squares and the x minus 2, I can plug in any value of x that I want. Okay. And then if I plug in a value of x that's convenient for us, this whole term can go away. So think about it. If I plug in x equals 2, right, which is basically where this guy is equal to 0, I can get a solution. So let me plug in x equals 2. I'm going to get negative 2 squared plus 2 times 2 plus 4. Then I'm going to get a times 2 minus 2 squared plus b times 2, 2 minus 2 plus c times 2. And notice that if I do that, this 2 minus 2 is 0, so this goes away, and this goes away as well. So in this case, I'm going to have my calculator over here because clearly my mental math is going to be terrible. So on the other side, I'm going to get a positive 4 is equal to these two go away, and I have a 2c left. So notice that this made it a lot easier to work with. So now I can just divide by 2. and c is equal to 2. Okay, so it's a lot easier to work with. Okay, so now I know what c is. Now let's go ahead and plug in something that might help me find what a is. Okay, so notice that if I go back to my blue part, notice that b and c both have x's by themselves. If I make x equals 0, okay, that can be something that's really, really useful for me. So I'm going to let x equal 0. So I let x equal 0. You're going to get, so the first guys are going to go away. So you get 0 plus 0. You get a 4. The a, you're going to have 0 minus 2 squared. Then this guy and this guy is also going to give me 0. 0 plus 0. So you're going to end up with 4 equals, it's going to be a 4a. So then a equals 1. All right, so all of this is really nice. And now finally, let's go ahead. So before we continue, you might be wondering, how are you getting all these numbers? One way to really think about it is that look at the denominator, the domain of the denominator. Whatever is not equal to each other, that's the thing that you want to set equal to. So here, whatever the denominator is, see how x couldn't equal 2 and x couldn't equal 0, those are going to be the values that you want to plug into this guy. All right, now we got to figure out what b is. Okay, now b is a little more tricky, but the thing is, like, we already know what a and c is. Okay, so we already know what a and c is. So we already know we got negative x squared plus 2x plus 4 is equal to, I know what a is, that's just 1. X minus 2 squared. We already know what b is. B is, no, actually we don't know what b is. And then I already know what c is, so that's just 2. All we really need to do is plug in any value that we want for b in this case. Okay, any value that we feel like would be nice. Okay, but as long as this term doesn't go away. So I think a really good value for b would be maybe, I don't know, let's plug in 3. X equals 3. So I'm going to have negative 3 squared plus 2 times 3 plus 4. So here, when I plug in 3, I'm going to get 3 minus 2, which is 1. So this is going to be just a 1. You're going to get b times 3, so that's 3b. 3 times minus 2 gives me 1. And then 2 times 3 gives me 6. So on the other side, you're going to get 9 plus, no, that's negative 9, plus 6 plus 4, that gives me 1, okay, is equal to, this is going to give me 3b plus 7. So I subtract the 7 over, negative 6, so then I get b is equal to 2. I divide both sides by 3, so I get negative 2. So now I got all of my answers. So if I go back up, my partial fraction decomposition, this guy's going to be a, which is 1 over x. B is negative 2 over x minus 2. And then c is 2 over x minus 2 squared. So this is going to be my full answer. Now, my claim here is that you could have plugged in any number. So if you would have plugged in x equals 4, you would have still gotten the same exact answer. So this, I think, would be a really quick way to do it. I mean, you can always just go ahead and FOIL everything out and have it as a system of equations as well. But I think this is also a really quick and easy way to just get all these values. Okay, so now let's go ahead and do this next example. This one's not as scary as the other one. So all we just have is repetitions here. So, and luckily for us, this is already factored. So this is going to be a over x minus 1 plus b over x minus 1 squared. So not something too bad. So let's rewrite this. So 6x minus 11 over x minus 1 squared. A over x minus 1 plus b over x minus 1 squared. So we're going to multiply everything by the denominator, right? So the denominator, right, was x minus 1 squared. So every single term is going to be multiplied by x minus 1 squared. So here, these guys go away. So I'm left with 6x minus 11 one of the x minus 1s go away, so I'm still left with just one left. And then here, both of them go away, so I'm just left with b. So now all we really got to do is plug in numbers, or you can set up a system of equations as well. Okay, whatever you'd like to do. Actually, setting a system of equations, I think, might be a little easier to work with, but whatever you feel comfortable with. We can also plug in numbers, so let's go ahead and plug in numbers just in case. So we can plug in x equals 1. So we're going to get 6 times 1 minus 11. And 8, 1 minus 1 plus b. This goes away. So we got 6 minus 11, that gives me negative 5, equals b. Okay, so we got b already. And now let's plug in any other value now that we know what b is. So we can plug in x equals, I don't know, x equals 0. So 6 times 0 minus 11 equals 8 times 0 minus 1 plus b. And b in this case is now negative 5. So this goes away. We got negative 11 equals negative a minus 5. Add 5 to the other side. And negative a equals negative 11 plus 5. That's going to give me negative 6. So a is going to be equal to positive 6. So now we got my answer. So my partial fraction is going to be 6 over x minus 1 plus negative 5 over x minus 1 squared. Okay, so here it's just using the shortcut. Again, yes, you could have set it as system of equations by gathering all the x's. And you'll see that you can actually get the same thing. Let me just write it on all the way in the top. So if I wanted to have that 6x minus 11 equals, and if I FOIL this out, ax minus a plus b, you would have still gotten exactly the same thing. Because notice that you would have gotten the 6x and the ax. So that would have been 6 is equal to a. So you already automatically get that one. And then you also get the next one. The negative 11 and the a plus b. So negative 11 equals negative a plus b. I already know that a is negative 6. So when you add the 6 over, you get that b equals negative 5. So even if you set it up this way, I think this might happen a little quicker than plugging in numbers. It really is up to you. Depends. I think the more complicated the problem is, just like how it was before, the easier it is to just plug in numbers. And the more simple it is, I think it's just better to equate the coefficients instead of just plugging the numbers. But then again, it's really up to you. It's rather preference. So we'll do the next example in the next video.